Okay, welcome to this Technology Leaders Club interview following a recent roundtable dinner. I'm joined by Jasson Casey. Jasson, please, can you tell me a little bit about yourself and who you work for?
Sure. My name is Jasson Casey. I'm the CEO and co-founder here at Beyond Identity. Me and about 4 or 5 other folks started this company back in 2019. And the founding idea was most people's identity stacks cause most people's security problems. And we thought we had a way of changing that. And fast forward to today, we've got a ton of customers that use us to protect their existing identity platforms, whether they be Microsoft, Okta, Ping, you name it. We secure their identity to make it simple and easy for their workers to log in, but actually prevent a lot of the headlines that you read about in the news today.
And I think that maybe answers the next question, which is, so we're speaking on the back of an event that was hosted a few days ago at the time of recording in Boston, and it was called Identity Security, the First Line of Defense. And I was going to say, could you explain a bit about the title and why it's so important? But I think you've done that already. But perhaps is there anything else you'd like to add?
Sure. Let's just double click on most of your problems come from the identity stack. What do we actually mean by that? There's another talk I give where in the first 5 to 10 minutes of the talk, I actually enumerate 5 breaches that you may have read about that all occurred in the last 6 months and were all fundamentally identity failures. Whether we're talking about the US Treasury and the compromise of secrets from the secret vault, whether we're talking about Salt Typhoon, whether we're talking about Volt Typhoon, whether we're talking about Australia Services, or the active ransomware campaign being run, I think the group's called Mamba. Every single one of those is exploiting the existing identity stack, whether it's exploiting some sort of secrets-based authentication, right? If a secret moves, it can be stolen, which is why it's so hard to defend. Exploiting things like push notification, right? Push notification and TOTP, they really have no bearing on what you're doing on your computer. It's just, it is a second factor, but it's a random second factor. And adversaries have shown us it's trivial to either overwhelm the end user, i.e. push bomb, or trick the user by man in the middle of the connection, compel the user through social engineering to go do a thing. And little do they know, they're running through infrastructure controlled by the adversary that then allows the adversary to hijack their session token at the end of the authentication process, which the user thinks they're doing, and it looks all correct. And that was Australian Services, that was Mamba, that was a variation of the Typhoon exploits. And obviously, this is the tip of the iceberg.
Yeah, so still, it's obviously a massive issue. And turning to the session itself, you covered a lot of content, and we'll come on to that as we go through this. But we were looking at the role in identity security and preventing like modern attacks. And how did the delegates respond to that? So you've I'm obviously they're up to speed on all of these things, but is it something that perhaps I know, frightens them in a way, and that was perhaps a reason for them attending the event?
So, obviously, I would say everyone's heard of one of those breaches. But when it comes to like the tactics or the techniques used by the adversary in each one of these, it's always a little bit of a surprise to the audience. And it almost doesn't matter whether it's a CISO, a CTO, a security leader or not. They're almost always surprised because in their mind, session hijacking is in the realm of a sophisticated actor, right? Man in the middling a connection is in the realm of a sophisticated actor. And they're just, a normal business, right? Russia's not coming after them. China's not coming after them. So they have to deal with the run-of-the-mill cyber criminals. And so when I kind of walk through in detail, how the attack worked, how it was carried out, and the fact that if we all remember, like Metasploit, it's like the open source package to really kind of jump onto from the 2010 to the 2020s. Their new open source packages, Evil Gen X, I would call, it's the new Metasploit, if you will, of identity-based exploits. And very little thought, downloading that open source package, pointing it at a target, and a little bit of social engineering, and you too can hijack a session token. So the point is like these aren't in the realm of sophisticated adversaries. They're in the realm of any adversary. And they're based on fundamental architectural failings of the identity stack when it comes to how authentication is handled, the fact that we actually are putting part of the burden on a human to execute what is a computer protocol for authentication, Like that's fundamentally flawed. Using credentials that move is fundamentally flawed, right? A credential that moves leaves a little footprint or a shadow of itself in every piece of silicon it ever touches. It's why you can't defend against this. And, the modern engineer doesn't build a simple server and a simple client. The modern engineer goes shopping at the store of Amazon and Cloudflare and Azure AD. And before you know it, they have 6 or 7 third parties in your architecture opening your TLS connection. So anything that you rely on the privacy of TLS just completely goes out the window, right? In the essence of developer speed and developer productivity. And so I would say, like, almost everyone's heard of some of those breaches. But when we get into the TTPs, what surprises most folks is that the techniques are actually available pretty much for any adversary, not just the sophisticated adversaries. And then the second thing that surprises them is that not all authentication techniques are strong in the face of these types of TTPs. Push notification is not a defense against these techniques. TOTP, right? Pick up your phone and punch in that code, is not a defense against these techniques. Using a phish-resistant, passwordless multi-factor with a biometric authentication on a secondary device is actually not a defense to these TTPs. And if you come to our YouTube channel, we've got a bunch of videos where it's literally like pick your platform, right? IDP and authenticator combination, and we show you an exploit, usually using EvilGen X3, of how that system is effectively compromised and the session token is jacked. But there's the logic, right? Like me showing you. There's the heartstrings, right? Like just look at your brethren that have been breached in this way. But then there is then there's just the reference in that, like, if you look at organizations that have a huge amount of risk, have been bitten by this problem before, or that are just very security conscious, they're using something called single device multi-factor phish resistance, where they guarantee credentials don't move. They also pull the human out of the loop in authentication. And they're tying in some form of device posture as part of that authentication and continuous authorization. Because just like at the airport, it's not enough for you to be the ticketed passenger to let you on the plane. You and your bags need to also be safe enough to allow onto the plane. So I think computer security is kind of catching up to a more modern, holistic view of how real security applies authentication and authorization. And I think the insight that we have is it doesn't actually have to be painful on the user. There's actually an opportunity to lower the barrier, make it even easier on the end user for them just to get to work.
We talked about some of the like practical applications of zero trust principles that kind of assess the user device and also the user and the device risk. Are there some good examples of that, and how well used are they today?
So if we're talking about the market in general, I would say we're really in the early stages. It's really only it's not even the early adopters. It's almost like the Mavericks and the Explorers are truly leveraging zero trust. And I'd be willing to bet a third of the viewers of this right now are saying, no, we don't. We use zero trust. We deployed this ZTNA product or this microsegmentation product, which I would argue is like it's a pillar of zero trust. But when you really think about your architecture, whether we're talking about your data or your services, whether we're talking about your employees, your contractors, the unmanaged devices, the third-party unmanaged devices, the common thing is all of those, whether they report to you or not, whether devices are managed by you or not, the common thread is they all represent risk to your data and your services. So you're on hook for making sure that they are compliant, whether they work for you or not, whether the devices are managed by you or not. So what is the one highway that everyone has to cross to get to your data and services? I'll give you a hint. It starts with an I. It's identity. So the identity system, unlike the network, right? Because in the modern architecture, you've got physical network, you've got cloud network, you've got private cloud network, you've got all sorts of interesting hybrids. And so you really have this heterogeneous collection of network. But the one thing that is common is your identity system. So the one place where you actually can tie access to who are you, what device are you operating from, what geography are you operating from, and relative to what you're asking for, is your device secure enough? Is your device compliant enough? Recording that in the moment, proving that in the moment, providing access, and then ensuring that that stays true during the time of access and withdrawing access if that goes away. That's really what a modern trust approach is all about. And the cheapest thing you can do in time and dollars for the maximum return of getting that kind of zero trust infrastructure in place, whether it's with us or someone else, is actually leveraging your identity system in zero trust. It's the control plane that sees everything, whereas your network is really just a data plane, and you probably have a couple of them, and they probably are not that interconnected except through the internet itself.
Another topic you looked at towards the end was some of the risks and opportunities that AI introduces to identity and access management. I'm sure it's a topic that gets sort of thrown up in all conversations. So, how did that discussion sort of play out in a particular way? Was it more in favor? Was a balance in favor of risks or the opportunities it presents?
So the discussion was actually pretty interesting. I would say we mostly talked identity and a little bit of AI as we were everyone was arriving. We were having drinks. Most of the dinner conversation actually went a bit afield. We were talking more about quantum computing, quantum complexity, post quantum crypto, with a little bit of a detour to the scientific renaissance from the 1700s. But the bit that we talked about on AI really comes back to AI is being used by the adversaries in a much more nimble way than companies have figured out how to use AI themselves. Right. So I think you could put AI really on a simple scale. Right. We'll call it the Kardashev scale of AI, if you will. Level one is, are you using it yourself to do just a better job? Right. Level two is, are you using it to change the way that you even work and build? And then level three is, are you using it in such a way where you're enabling your customers to change how they work? I think most organizations are still on number two. I'm sorry, on number one. I think adversaries have now actually advanced to number two. And we now have, it's been theoretical for, I'd say, 3 or 4 years, but it's become practical in the last 18 months. We now have evidence of the adversaries changing how they work, right? Their social engineering texts look just like how their target writes. Their offline voice and video is a perfect clone of their victim or their target. Their real-time voice and video is surprisingly good, so good that it can now fool, right? There's the bank case, the was it $25 million fraud theft out of Hong Kong. There was the Italian defense contractor from like 4 to 6 weeks ago. There was a U.S. senator from 2 or 3 months ago, and these are just the well-publicized events. The adversary has not just figured out how to use AI to do their job better, it's changing how they work, right? So if the adversary is AI enabled and they're coming after your organization, what do you do about it? How do you do about it, right? And there's two. I would say there's one strong thought that's certainly popping up a lot, which is, hey, I need to detect all of these uses of AI, and if I can detect all of these uses of AI, then I can alert the SOC, and that's step one. And my response to that is probably not appropriate, but my tame down response to that is, it's never going to work. And I think there's 2 arguments for why that's never going to work. Number one is very technical, which is really good generators can be used to, I'm sorry, really good detectors can be used to train generators. So a good detector today is used to train a generator that can defeat my detector tomorrow. So you get in this arms race, and there's clearly going to be a bottom where things are indistinguishable. And I don't know if you get there through computational power. I don't know if you get there through new models, but I do strongly believe we'll get there, and we'll get there quickly. So that argument is just an argument for efficacy, that it's just not going to work over time, and you're just wasting your money. My second argument has nothing to do with technology. My second argument has to do with the benefits of AI. I want to use AI so that you hear me in Japanese because you're my Japanese argument. I don't know Japanese. I want that real-time voice translation. I got kicked in the face by a horse this weekend. I don't want you to see all the bandages and whatnot, and you don't, because this real-time AI is perfect, right? I want it to be a copy editor and to really improve my writing before I send it to people on email or even public posts on blogs. So even if I had perfect detectors, what do they do in the case where it's intentional usage for all of these valid purposes? So we argue that's a bankrupt area and a dead end. First, for reasons of technology, eventually it's going to stop working. But even if you assume it didn't stop working, it's going to get in the way of all of these positive, high value uses of AI. So if we can't solve it in that way, what's a better question to ask? And we strongly believe the better question to ask is not, is this AI modified or AI generated? A better question to ask is, where did this come from? Did this come from Jasson's computer? Was Jasson's biometric used in the production of this content? Is any of that provable in any sort of way? And so, an identity system that's built with security principles that uses these things we call device-bound credentials and deep device posture, when it integrates to these downstream applications, whether it's Zoom or Teams or Outlook or even software development tools like GitHub and GitLab, one of the benefits you should get out of these systems is all of a sudden you have the equivalent of a cryptographic signature over all of this content. So you always understand where this content came from. And you may not be able to, in the long run, stop certain instances of the adversary injecting their version of content, but they won't have the proof that it came from my device. They won't have the proof that I use my biometric to author it. And we can go on and on and on, but that's a more viable solution to the problem. It's a more scalable threat model. When you really think about that, the threat model has now been reduced to like physical theft, like the adversary has to physically steal stuff. And from a scalability perspective, the reason ransomware works so well is it's like putting a dandelion in the wind, right? Wherever it may land, I'm going to rock. Whereas if it's physical theft, I need to follow you around. I need to figure out when you're going to the bathroom at the coffee shop to steal something. And even then, there's a lot of things that you can do that are just much more advanced than today. So when it comes to AI, we really challenge our customer base and our operators to think about not how do I detect AI, but how do I defeat an AI-enabled adversary by really understanding like provenance and chain of custody of the content that's coming from them.
Anything or any other sort of summaries or thoughts having walked away from the evening that you sort of took away with yourself? Oh, you mentioned the Renaissance and some sort of maybe more, let's call it more off topic, but clearly obviously an interesting discussion on the evening. But any sort of takeaways or thoughts you had post the event?
It was a good event. It was a good group of people. I was a little bit worried that we went so off topic, but I actually enjoyed myself. And the way we got off topic was, there's always someone in the audience who's like, well, wait a minute, what about quantum, and what about this, and what about that? And I'm not an expert in quantum mechanics or quantum mechanical computing or anything like that, but I do know a thing or two about complexity theory and the math, if you will, of how computing works and why we believe in the strength of certain cryptography algorithms. And I was just the conversation proceeded to is like we can talk about quantum resiliency and post quantum, but there's really kind of there's a couple things we always want to keep in mind. One is not every job from a cryptography perspective is about privacy or secrecy. Sometimes the job that we're looking for is like integrity. I just want to know if this has been modified, or integrity under authentication. I just want to know if anyone's modified it other than Jasson, right? And so when you force people to break things out in that way, their fear of what if a quantum computer exists that can factor a discrete logarithm, i.e., it can kind of decrypt everything that we've ever talked about. That's clearly bad if we're talking about intellectual property, if we're talking about state secrets, if we're talking about something where the function is literally the preservation of that information, or not the preservation, but the secrecy of that information. But it becomes a little bit more nuanced when we're talking about, well, what if it's an audit? What if we're just trying to track who did what, right? Well, if it became available, clearly I could forge entries in that log, right? Because I can factor these discrete logarithms. I can essentially reverse engineer a signing key, and I can use that signing key to produce new data, right? But again, the threat model's changed, and the defeat against that is under the conjecture that these post-quantum algorithms are actually secure against quantum and pre-quantum computing. Then just sign history, sign the log with one of these new techniques, right? Whether it's I always get the names wrong now. It's like because it's like a bunch of sci-fi shows, right? It's like Kyber, and then there's another one that's like the lithium. It's like they're what kind of crystal stuff can I use out of Star Wars and Star Trek? But anyway, I'm getting off topic. The gist of it is there's an equivalent way to sign something using a post quantum algorithm. And if I really am worried about things like authentication logs and audits against quantum, the simplest thing I could do is I can actually just start signing over the history of my logs using a post quantum algorithm. It doesn't mean that someone can't forge, right, the old keys, but under the conjecture that this is a hard algorithm, they can't actually insert it under my signing without me understanding. So actually, I think we have it a little bit easier in the identity world than say someone who's really worried about like DRM or the secrecy of data itself. Um, and you know the advice that the government gives and really everybody gives is, hey, build your product. Just know that there are these meta operations, right? Like encrypt, decrypt, sign, verify, and build your systems to be. They call it quantum or crypto agile or algorithm agility, and all it really means is just make sure it's easy for you to change a library later on to where the thing that you're signing with can just be switched out. And it's clearly not that trivial. There's a little bit more plumbing you have to think about, but I don't know. I don't see it as massive of a problem, especially for like a new, more modern technology company. Um, and so then we went into, well, wait a minute. That's how do we handle it? But like, how real is it? When am I really going to get a quantum computer? And that was where I was just directing folks to read Scott Aronson's blog. He is a professor at UT. He actually is an expert in quantum complexity as well as a couple other areas in this field, and he has a pretty good take on where are we in the life cycle of solving things around error correction and stability. When you compute things quantumly, you want the answer to stick around long enough for you to be able to read it, right? And when you scale up this process, it's not enough to work with a few qubits. You want to work with a lot. So how do you make sure, if anything is staged, that the output from one is going to live long enough to be the input to the next stage? And anyway, long story short, Scott Aronson's got a really good blog, Shuttle Optimized, that I was just kind of directing folks to. And then the other part of the discussion around the Renaissance, I forget who brought it up. Someone invoked Lord Kelvin, and I think my favorite Lord Kelvin story actually was based on him figuring out how to actually transmit the telegraph signal using undersea cables between the U.S. and the U.K. Back in his time. And so we talked a bit about that and how fascinating the story was. And then I referenced, like, I think my first introduction to the story was this short form article written by one of my favorite authors, Neil Stephenson. He's since written a ton of science fiction that's super famous. But he wrote this nonfiction really about how the internet was getting constructed in the 90s, and all these folks were laying oceanic cable everywhere. And then he contrasted it with the telegraph going mainstream. And what I mean by mainstream was really being globalized. And Lord Kelvin was the physicist / engineer who really figured out how do I send signals over such long electrical pathway where I can actually understand the signal on the far end and noise doesn't overtake it. And there's some really fun stories of the bozos who came before him and didn't really understand how to do it, and ultimately ended up ruining a lot of the prior investments in cables.
It's fascinating stuff. And what I'll do is when we publish this recording, I'll also link to those two articles and blogs as well. So,
oh, and the article was called Motherboard, Mother Earth Motherboard. I always like flip them for some reason in my brain.
thank you for that. And as I say, we'll share those when we publish it. Jasson, thank you very much for your time today.
Yep.